Hello everyone, Assalamu alaikum. I am Ashikilai Sadi and today I am going to discuss about MOSFET, which is a basic electronic device, and the MOSFET and it is vastly used. Okay, and why I choose this topic is because you see here is my mobile. Every mobile or laptop or your PC has a processor. It could be in laptop you use Intel processor or AMD Ryzen processor. In mobile you use Snapdragon processor or MediaTek processor. So every processor actually a combination of billions of transistors. So and MOSFET is a one kind of transistor. So if you understand the basic operation of a MOSFET, then you will understand how processor works or how the company like Intel, AMD, they produce produce processors through MOSFET. Okay. So that's why I choose this topic, and it seems very interesting to me, and it is also very important for your academic examinations and also for job preparation. So in today's class, first we will discuss about the basic operation of a MOSFET, and then we'll come into the equations that you can use in your mathematics. Now first, what is a MOSFET? Basically, I have drawn a figure of a MOSFET here. You see. So in a MOSFET, and basically this is the N-channel MOSFET, and in an N-channel MOSFET you will have an N-type dope region, here another N-type dope region, and a substrate in between which is P-type. And first of all, and we also have to remember that every MOSFET has three terminals. They are source terminals, gate terminals, and drain terminals. Okay. Now if you apply a voltage in the drain to source terminal, in this case, if you not apply any voltage at the gate, just in the drain to source terminal, then you will get no current. And further going into the depth, I want to clear one thing, that here you see this is N-type region, this is N-type region, this is P-type region, and this is oxide layer. That's why it is called metal oxide semiconductor. Basically we use silicon dioxide here, and this is also a metal. As a result, you see this is like a capacitor. You remember you have studied in your earlier classes what is a capacitor. If you put two electrode here, the positive electrode and negative electrode, and a dielectric in between, then it will form a capacitor. So in a capacitor, if you give positive charge here, a negative charge will be induced, and here is one electrode here, this is one electrode, and there this semiconductor works as other electrode, and this is the dielectric which is silicon dioxide. So first of all, we don't apply any voltage to gate. Now if we apply drain to source voltage, we will get no current. You can ask me why. The reason is, as this is the P-type and this is N-type, here in the N-type electron is the majority carrier, in the P-type hole is the majority carrier. As a result, you will get a depletion region in this area and in this area. As a result, if you apply drain to source voltage, there is no channel formed and you will get no current. But if you apply a gate to source voltage, like you apply a positive voltage at the gate, then what you will get? You see that if you apply positive voltage at the gate terminal, then due to this MOS capacitor action, you will get negative charge here. For this positive voltage and this capacitor action, you will get a negative charge here. As a result, this will be a channel. Okay. Now when the channel is formed, if you apply drain to source voltage, you will get a current from drain to source, which is electron will flow from source to drain as you form the channel here. Okay, I think you have understand. Now if we draw the drain current versus drain to source voltage characteristics for a MOSFET, for n channel MOSFET. And the one thing that why we call it the n channel MOSFET, because you see the channel is formed through the n type region, and that's why we called it n channel MOSFET. And for p type we use PNP. Okay, we won't talk about it now. And let's see the ID versus VDS characteristics. So here you'll see that if we don't apply any voltage at the gate to source terminal, no channel will form, and as a result you will get no current, and the curve will be like this. This is the curve when the gate to source voltage is 0 volt. You will get no current ideally, but in practical we will get a small current which is in the nanoampere range. It is because of the tunneling current phenomena. We won't talk about it now, but it is very interesting. You can search it. Okay, now if we apply here our gate to source voltage was 0 volt. Now if we increase the voltage and the gate to source voltage is 1 volt, then we will get a significant current here. You will see for gate to source voltage 1 volt, we will get current like this. And why the current increases? Because here for gate to source voltage 1 volt, there is a channel formed here, and if you now apply drain to source voltage, the current will go from drain to source. If you further increase the gate voltage to 1 volt, from 1 volt to 2 volt, you will get higher current, because the channel will be formed now strongly. So we see for gate to source voltage 0, we are increasing drain to source voltage, but current is 0. But if we increase the gate to source voltage, the drain current increases. Now look at the picture, look at this diagram. You will see in the graph that there is two regions, the linear region and the saturation region. Here you see the current is increasing almost linearly with the drain to source voltage, but almost saturated in this region. And so transistor works in these two modes. The linear mode, you see the transistor works in two modes, the linear mode and saturation mode. Okay, now we will talk about the equations for MOSFETs. Okay, first of all, for every math of MOSFET, you have to check two things. First of all, you have to check that channel is formed or not. Channel is formed or not. How will you check that? For n-channel MOSFET, you have to check that VGS is greater than or equal VT or not. What is the VT? VT is a threshold voltage. It will be given in your question. You need not to bother with it. This is a threshold voltage. So if the gate to source voltage is greater than the threshold voltage, then for n-channel MOSFET the channel will be formed, and in this case if you apply drain to source voltage you will get current. But if VGS is not greater than or equal VT, which is VGS is less than VT, then if you apply drain to source voltage in this case, you will not get any current, you will get no current. Why? Because for VGS is less than VT, the channel won't form, and the channel will not form, and as a result you will not get any current. If the channel is formed, which is number one condition gone, the channel is not formed, then you have to check if it is in saturation region or linear region, because the drain current equation for saturation region and linear region are not same. You see how you will check that the MOSFET is in saturation region or not. You have to check that VDS is greater than VGS minus VT. If you see that drain to source voltage is greater than VGS minus VT, then you can say that the transistor, the MOSFET is in saturation region, and you can use these equations, which is ID equal to half mu n Cox W by L VGS minus VT whole square. And here the question will give you the value of mu n Cox W by L. Just you have to work with the VGS, VT and ID. Okay. Now if you see that VDS is not greater than VGS minus VT, you will take that the transistor is in linear region, and now we have to use ID is equal to half mu on Cox W by L to VDS into VGS minus VT minus VDS square. You see one interesting thing, that in linear region the drain current depends on the drain to source voltage, which is you are applying the drain to source voltage. The in linear region drain current depends on the drain to source voltage, but in saturation region the current is not dependent on drain to source voltage, rather it is almost constant, which we are seeing here. The saturation region the current is almost constant with drain to source voltage, but in linear region it is increasing with drain to source voltage. So, and that was the all equations, and if you memorize just these three equations and the basic operation I have talked earlier, I think you can solve all the mathematical problems or theoretical problems in your examinations. And that was all for today. Thank you everyone for listening. Assalamu alaikum.